Eminent speaker Dr. Ajeet Kumar Pandey is System Assurance Lead at Atkins. Dr. Kumar obtained Master degree in Software Engineering from Motilal Nehru National Institute of Technology, Allahabad, India, and PhD in Reliability Engineering from Indian Institute of Technology, Kharagpur, India. He has 20 years of experience in system assurance and RAMs, wrapped up with cross functional domain knowledge of metro and rail industries. His core competency and research includes system assurance, railway RAMs, software safety, and reliability. He has worked for many MNCs such as Cognizant, Acom, Alstom, D. Apollonia, L&T, and Atkins. He traveled many countries: Australia, Japan, France, USA, Qatar, Indonesia, UAE, and Malaysia for the work and contributed to many metro and rail projects such as Etihad Rail UAE, Dubai Metro Extension, Expo Link 2020 Dubai, R2P Germany, DFCC India, LR3 Malaysia, Jakarta LRT Indonesia, Network Rail UK, Sao Paulo Line 6 Brazil, Jakarta MRT Indonesia, Delhi Metro Line 8 India, Doha Metro Project Qatar, Sydney Metro Australia, Hyderabad Metro India, and Invencis Rail USA and UK. He has to his credit a number of research papers, articles, and books on system assurance. Dr. Kumar has also delivered invited talks and conducted short term courses for various institutions and industries globally, like IIT Kharagpur, ASCI Hyderabad, NIT Patna, NIT Warangal, IMRT Hyderabad, JNTUH Hyderabad, GBU Greater Noida, Atkins Gurgaon, L&T Metro Hyderabad, HBL Hyderabad, Thales Bangalore, Open Access Malaysia, PMCC Malaysia, and Rapid KL Malaysia. And a very warm welcome to you, sir.
Today I will be presenting the issue and challenges towards implementation of system assurance and RAMs to the rail projects. This is myself in brief, my education, what are my earlier companies, what are the projects I carried and contributed in different capacities. And currently I'm working as a system assurance expert in Larsen & Toubro Dubai branch. And these are my coordinates. This is the agenda for the today's discussion. I will be focusing on the basic concept of system assurance and RAMs. RAMs management, which is the one of the vital activity of system assurance. What is RAMs? Why RAMs? How RAMs? Railway RAMs in the practice overview in the rail industries. How we are implementing RAMs in the rail industry. What kind of rail? Maybe high speed, bullet train, monorail, metros. And what are the key standards in the railways across the globe? I will be briefing. And what are the issues and challenges we are realizing in different projects, and how we could overcome these challenges. So I proposed one progressive RAMs management model that I will be summarizing all these things. So this is the first slide, which will be briefly explaining about the system assurance. System assurance activities are required for new or upgraded railway systems in order to ensure the fundamental activities related to safety, reliability, availability, and maintainability are considered across the project life cycle. The key point here, system assurance is the birth to death activity of a railway project, starting from the concept till commissioning. And if you can see the below, there are many activities. If you say there is one project, project one, RAM, safety, EMC, VNB. So this is the SA activity of project one. This is the SA activity of project two. There are 5, 6 activities. There are 8 activities. There are 10 activities. The biggest confusion or biggest misunderstanding across the different projects, what to include, what not to include in system assurance. Obviously, you can see RAM and safety is common to every project. It means RAM is the core. RAMs is the core of system assurance activity. So, if we want to specify what to include, what not to include, there is no standard, there is no guideline around the world which can say this is the only belongs to system assurance and this is not belongs to system assurance. So it is the client responsibilities to consider what to include, what not to include. So to me, I can summarize in simple way, system assurance means RAMs plus other system engineering activities to achieve RAM's objective. So just to brief you, system assurance is the umbrella activities where the RAM and safety is the key activities. Apart from RAM and safety, there are many other system engineering activities which are indirectly or directly supporting to achieve RAM goals. So here system assurance process provides a guideline, provides a guidance for integrating complex and multiple technology systems. So whenever we are working in a project which is having complex and multiple technologies, obviously in railway itself an engineering environment from civil engineering, mechanical engineering, electrical engineering, electronics engineering, software engineering. So railway is a integration of multiple technologies, and obviously without system assurance, it is very hard to achieve those system assurance goal. So system assurance is the most useful aspect of the railway projects, and basically it is a holistic engineering management approach to integrate multiple technologies seamlessly. And I have worked in many projects. Some projects they call RAMS management and system assurance. Obviously, RAMS management is a subset of system assurance. So what system assurance activities include? I just highlighting here in summarizing: RAM, safety, EMC, configuration, interface, verification. And what SA does not include. This is very important to focus, because SA team should be always independent from design team, because design team will do their design and SA team will ensure that design is meeting the RAM and safety target. The design is the different part. Health and safety is the obviously is the independent department. Quality is the different department. Environment and sustainability. So what SA should include and what SA should not include. So this is the basic concept of system assurance and RAMs. How RAMs and system assurance are linked together. So now, since we are focusing on RAMs is one of the most important elements of system assurance. When we're talking RAMs, the two words RAM and safety. What is RAM? What is safety? Why safety? Why RAM? When RAM? So once we talk about RAMs, it means failure. You can see here, system fail, faulty state, we can repair, working state. So how system fail, how we can repair. The whole story of RAM and system assurance is centered around this. Because in railway project, there are many systems: rolling stock, signaling, traction, power supply, telecom, track, depot. So every systems collectively to achieve a common goal. If any system fails, the whole project will fail. So how to control those systems, how to control the failure of those systems with respect to safety and reliability, we are focusing on the RAMs management. So that is why RAMs is the vital aspect in system assurance, where we can control the failure of any systems which is a part of the railway project. Just I have taken one example just to explain the importance. Suppose there is 5 systems. There are 5 systems, and I want to achieve the availability of 95%, a reliability of 95%. If all systems are 90% reliable, so overall reliability becomes only 59%, because all systems are supposed to be in series. Similarly, if all systems are 100% reliable and one is 85%, the reliability becomes 85% only. If all are 95%, the final will be the 77%. So how to assign the target individual system so that they can achieve this 59%? That is the biggest problem in the industry, because in most of the railway projects, I have seen that the RAMS targets are simply borrowed from one project to another project. Whether the different projects have different alignment, different speed, different kind of design, underground, elevated. But I have seen the contracts are almost similar, because there is some lacking in understanding how to apportion the RAMs target and safety target among the systems. That is the key problem, that is the key challenges which we are facing. And definitely with this forum, I would like to request all the industries So we have to come on some solution how to standardize the RAM apportionment and safety apportionment to the different systems and subsystems depending upon their uh, complexity and usefulness. So what is RAMS management? RAMS management, there is system engineering team, there is a RAMS team. So system engineering teams is well known. When RAMS concept was not there, they are already doing applying good engineering practices. They are doing verification and validations. They are doing configuration management, installation operations. So once the concept of RAMS came, again we have to establish one team, RAM and safety team. They are simply authenticating, endorsing the system engineering team that they are aligned with the RAM and safety target. So RAM's team from concept to commissioning, they are aligned with design team, VNV team and other teams to ensure that RAM and safety aspects are progressively achieved. So RAM's management helps to integrate RAM and safety characteristics into the product and project systematically across the project lifecycle. Moreover, it also provides a process framework for railway authorities, railway support industries to ensure that they have been designed, constructed, operated, considering all critical factors related to RAM and safety. So RAMS management provides a guidelines for the client as well as contractor. Client, how to specify RAMS target, and for a contractor, how to achieve RAMS target in the design and development stage. Why RAMS? Because of many reasons. Why we need RAMS? The first answer should be quality of service. We want to improve the quality of service. Our train is punctual, our train is on time, our train is comfortable. There are many reasons. So quality of service is the first reason, and quality of service is highly influenced by the railway RAMS apart from other attributes. So if we summarize why we need RAMS, I have considered few points like rising performance requirement. So nowadays, our metro system, railway systems, we want high quality railway system. We want the trains reach on time. There is a speed. There is a comfort. There is a many things. Now we are in future we are planning to connect the railway in the IoT, Internet of Things, clouds. So these things somehow we want the performance, and performance can be evaluated and measured with respect to some metrics, that is RAM matrix. Similarly, balancing life cycle cost. In project, we want to optimize the life cycle cost, cost of running cost, warranty cost, asset management cost. So all the cost optimization cannot be achieved without RAMS consideration, because RAMS will give you the failure time, repair time, when it will going to fail next time, how optimally we can maintain. So life cycle cost cannot be optimized without the RAMS consideration. And legislation requirement. Of course, in some countries, even in my countries also, in our countries, in our project also, some clients has specifically mentioned contractors should comply with this standard. Contractors should supply the with seal certificates. So, depending upon this legal requirement, we want to implement RAMS as well. And filling between the technical and operational performance, this is the most appealing factors, because same systems we are using in one project and in different project, performance is varying. Why? Because different project they have implemented RAMS very well, and some project they have not implemented RAMS very well. So RAMS is a tool to fill the gaps between technical performance versus operational performance. How RAMS? RAMS we can implement through this some tender document. So once this GS and PS, general specification and particular specification written by employer requirement, it is creating certain requirements. A requirement may be functional and non-functional, plus some RAMS requirement. So RAMS requirement, how to write RAMS requirement? If we don't have any pre-existing RAMS requirement, we can take help from the standards EN 50126, 128, 129. This standard will help how to write, how to specify RAMS requirement. Together, we can make a system requirement specifications, and requirement is given to all the teams, all the systems, and This is the engineering teams. Engineering team, this is RAMS teams from design, doing development and operational maintenance. Together they are working as per EN 50126. Once system has been designed and developed and ready for the handover, they will come CISA or ISA, safety acceptance and approval. So this is the way systems are implemented with context of RAMs from concept till handover. This is the practice overview. Just I categorize in a very simple way. Railway project, a metro project. There are three pillars, basically three major work: system work, civil work, and O&M work. So first civil work started, then system work, and then operational work. So RAMS is applicable everywhere. We want to design systems, reliability and safety. Civil work also, some safety and reliability required because there are many underground, there are many BMS systems. And once civil system work done, we go for the O&M work. The O&M work also, we want to demonstrate what we have designed for safety, it is meeting or not. So this is the way RAMS, with this slide, the objective is RAMS is applicable here, RAMS is applicable here and here as well. All the three aspects is required proper RAMS consideration. And this is the about the stakeholders. In any projects, in railway projects, they are typical stakeholders, and all stakeholders are a common objective. They want to deliver a safe and reliable railway project. This is a common objective for client, contractor, consultant. So suppose this is a client. Client may be your Delhi Metro, maybe your Mumbai Metro, maybe your Indian Railway, maybe other metro. So client, there is a consultant who are representing client. There may be contractors who are actually manufacturing or delivering these systems. There is a independent reviewers, and there is a independent regulatory bodies. So in typical, these are the 5 high level of stakeholders involved in railway project, and every stakeholders should have at least one RAMS expert, a RAMS representative who can understand the RAMS requirement, and this client RAMS representative can pass on their requirement to the consultant, and consultant can contractor, and so on. So these are the RAMS representative for every stakeholder. This is the usual practice to implement the RAMS. Nowadays, I have seen in some projects, client side there is no RAMS, they are dependent on the only contractor. So that's why there is some gap. So once client and consultant is having RAMS team, definitely contractor we can enforce and contractor can do this way. So this is the standard practice where RAMS can be implemented through the stakeholders. This is the deliverables. So to implement RAMS deliverables, we have 3 levels of RAMS deliverables. First, level 1, this is level 2, and final up to level 3. Level 1 means developed by the consultant and client. All are the management plans. And these management plans are giving the template and guidelines to the contractor. So once these plans are ready and is given to contractor, all contractors are using those plans to develop their respective plans and analysis. So this is the way RAMS will be cascaded in the project from high level to lower level. As similar way, this contractor having many suppliers, they can give their requirement to supplier and so on. So RAMS deliverables will be guided from the client to contractor to supplier. So these are the certain challenges I faced in my project, and just I want to highlight what are the RAMS management issues and challenges. So specification, how to specify RAMS target, because there is a mix of the specification method, design based, performance based. I would like to recommend you should follow the EN 50126 guidelines how to specify RAMS target. Again, I face the challenges. Design team is independently working, and there is no synchronization between RAMS team. So once design team is working independently without any RAMS team involvement, so once design is finished, we can't improve the reliability and safety. So to make the proper design, your design is meeting RAMS target, you must have a design review workshop with that RAMS team so that we can improve our design before it's going to be finalized. Lack of subject matter experts, as I mentioned, there is a few RAMS experts. That's why the person is not able to, the project is not able to take forward in the RAMS. So for that reason, I would like to recommend that there should be continuous training and awareness program inside the project, either from client side and contractor side, to create awareness so that this subject will be appreciated in the project. And lack of management support also, because of lack of awareness, in some projects they are not allocated some budget also. So lack of budget, lack of management support, document centric. Some projects thinks that RAMS is a simply document work. So because of that perception, simply creating a document will not solve our RAMS problem. Next is this is the approach how to do RAMS. So RAMS should be do progressive way. From concept phase, you design something, some RAMS requirement. In design, you do some RAM analysis, safety analysis, do some workshop. Then construction, you can verify and validate through some testings, some on-site inspections. Then do some trial run. Then you can do some commercial operation, then DLP. So RAMS, from concept till commissioning, there are certain activities recommended by the EN 50126. We have to find out what activities is applicable to what phase and what document need to be produced at what phase. And this is the standards, how RAMS standards are working around the rail industry. So this is the first standard in safety, IC 61508. From this standard, there are many industry-specific standards has been developed: automotive, avionics, railway, medical, nuclear process. So we are in railway industries. For railway, there is RAMS standards. RAMS standards is the EN 50126, 128, 129, 121, 159. So these three blue part, these are the key RAMS standards: 126, 128, 129. And this yellow part here, this is the latest revision of standards. So we have to take care what is the recent version of the standard we are using and what is the equivalent version of the EN, because some customer they follow IC standard. So IC standard, IC 62278 is the equivalent of EN 50126. So if you follow this standard, you can simply mention, yes, we are IC compliant of equivalent EN version. So this way, every standard has certain revisions and certain equivalence of IC, and in the project, we have to take care of which is the recent version, or what version is followed, and what system is complying to which standard. If you are working a system which is more software oriented, you have to follow EN 50128. For hardware safety, you have to follow 50129. So you can see here total railway systems, how EN standards are aligned and how EN standards are applicable to whole railway systems. This is the whole railway systems, only for hardware, 128 only for software. So applicability of RAMS standards is vary project to project and system to system. Some systems are more applicable to some standards and some are less applicable. But it's for sure EN 50126 is applicable for whole railway project as a rolling stock, as a signaling, as an infrastructure. So this is a summary. System assurance is a holistic approach and shall be applied across the project life cycle. It's not like the design, only design. No, from the start till handover. System assurance activities vary project to project, and RAMS is a vital component of system assurance and has a significant impact on safety and performance. All stakeholders must be involved in system assurance activities. It's not client will not involve. Standard says depending upon the roles and responsibility, some RAMS activities is assigned to everyone. So it is not an individual department individual stakeholders, all are, it is a joint work so that system assurance can be achieved. RAM's requirements shall be specified well in advance and shall be ensured during the design progressively at each design stage. IC 61508 is a generic standard to functional safety applicable to all electrical electronics industries. Three main standards for railway ramps derived from IC 61508 is the 50126, 128, 129. The first one, EN 50126, is generic ramp standards. It's like management of ramps. It's a management standards. And 128, 129 is the engineering aspect of ramps. How to develop, how to design. So together, 126, 128, 129 are the complete ramp standard in the rail industries. EN 50128 provides guidelines for software, how to develop software in rail industries, while EN 50129 is for hardware safety. Also, EN 50129 provides guidelines for safety acceptance and approval. Suppose you develop a hardware, you want to get for safety approval, acceptance, you have to comply with EN 50129. So, just to in a single statement, EN 50126, 128, 129 are group of ramp standard that must be complied for any railway project. So this is a summary, and hope I just brief you all the RAMS standards and how RAMS is practiced and shall be practiced in the railway projects. Thank you very much for your patience. Now I'm open for any discussion, any questions. Thank you very much. Have a good day.